Now next we need to find is the propagation constant of T network. Propagation constant of T network. By definition of the propagation gamma of the network is given by gamma is equal to log to the base E I1 by I2. Okay, so this is the by definition of the propagation constant gamma network. The figure which we had taken it before, I'll draw it again over here. This is Z1 by 2, this is Z1 by 2, this is Z2. It is terminated at the impedance Z0, which is known as characteristic impedance. We have a supply Vs. Okay, this is the port 1 dash, and this is the port 2 and 2 dash. Okay, circuit is closed, current is flowing I1 and current is flowing I2. Okay, now writing the mesh equation for the second mesh, that is the I2 mesh. Starting from Z1 by 2, I can write Z1 by 2 I2 plus Z0 I2 plus Z2 I2 minus I1 is equal to 0. Then I can write, taking I1 Z2 to the other side, I can write I1 Z2 is equal to I2 times Z1 by 2 plus Z2 plus Z0, or I can write I1 by I2, which is equal to Z1 by 2 plus Z2 plus Z0 whole divided by Z2, which is, this is equal to E gamma. Okay, because we know that propagation constant gamma is given by log of I1 by I2 to the base E gamma, which is equal to I1 by I2. Okay, can write Z1 by 2 plus Z2 plus Z0 is equal to E gamma into Z2, or I can write Z0 is equal to Z2 into E gamma minus 1 minus Z1 by 2. We already know that the characteristic impedance of a T network is given by ZOT is equal to square root of Z1 square by 4 plus Z1 into Z2. Now suppose this is equation 1 and suppose this is equation 2. Now squaring 1 and 2 and subtracting 2 from 1, that is squaring 1 and 2 and subtracting 2 from 1. So squaring 1 and 2. First we'll do squaring of 1, in which I can write z0 square is equal to z2 square e to the gamma minus 1 the whole square minus twice z2 e to the power gamma minus 1 into z1 by 2 plus z1 square by 4. This is the squaring of 1, and squaring of 2 will be zot square will be equal to z1 square by 4 plus z1 into z2. Now we will subtract 2 from 1 and we will get z2 square e to the power gamma minus 1 the whole square plus z1 square by 4 minus z1 into z2 e to the power gamma minus 1 minus of z1 square by 4 minus z1 into z2 is equal to 0. Next, I can write z2 square e to the power gamma minus 1 the whole square minus z1 into z2, will take it common, e power minus gamma plus 1 is equal to 0. Okay, now this is z2 square e to the power gamma minus 1 the whole square minus z1 into z2 e to the power gamma. This one and this one will get cancelled. This is equal to 0, and I can write z2 e to the power gamma minus 1 the whole square minus z1 e to the power gamma is equal to 0. Okay, because we have taken, or I can write one more step, that is z2. Okay, so this will get cancelled because of 0, and what we have is e gamma minus 1 the whole square is equal to z1 e gamma by z2. Okay, and if I break this, this is e to the power 2 gamma minus 2 e to the power gamma plus 1 is equal to z1 e gamma by z2. Or I can take this to the negative side, divided by z2 e to the power minus gamma. Okay, I have taken it down. Now rearranging the equations, I get e to the power minus gamma is equal to e to the power 2 gamma plus 1 minus 2 e raised to the power gamma is equal to z1 by z2, or e gamma plus e to the power minus gamma minus 2 is equal to z1 by z2. Okay, over here it is actually e minus gamma and e gamma. This will get equal to 1. So dividing both sides by 2, we have e gamma plus e to the power minus gamma by 2 is equal to 1 plus z1 by z2, taking this 2 to the other side, and what we get is a very important equation, that is, now this is equal to cos of hyperbolic gamma is given by e to the power gamma plus e to the power minus gamma by 2. So I can write cos of hyperbolic gamma is equal to 1 plus z1 by z2. We get this very important derivation. Divide this also by, this is 2 and this is 2. Because we are dividing by 2, I'll just show it here. This is by 2, this is by 2, which we get over here, and this is by 2. So we get the equation, that is cos of hyperbolic gamma is equal to 1 plus z1 by. Now we can also obtain another expression, may be obtained for complex propagation constant in terms of hyperbolic tangent rather than hyperbolic cosine, and in that also maths is involved, and sine of hyperbolic gamma is equal to square root of cos of hyperbolic square gamma minus 1. Okay, so this is equal to square root of 1 plus z1 by 2z2 the whole square minus 1, because we know that cos hyperbolic gamma is given by 1 plus z1 by 2z2. So this is equal to square root of z1 by z1 plus z1 by 2z2 the whole square. Okay, or to be more clear, you can write this to be 1 plus 2z1 by 2z2 plus z1 by 4z2 square minus 1. Okay, this one and this one will get cancelled, and this 2 and this 2 will get cancelled. What remains is z1 by z2. Okay, so I can write sine of hyperbolic gamma is given by 1 by z2. Okay, now I'll do some manipulation. That is, if I write this to be z1, z2 square and z2, I'm multiplying dividing by z2, plus z1 square by 4 z2 square, and if I take z2 outside, this is z2 over here, and this is z1 into z2. So you have sine of hyperbolic gamma is equal to 1 by z2 square root of z1 z2 plus z1 square by 4. And what is this z1 z2? What is this? This is equal to ZOT. Okay, ZOT by Z2. So I can write sine of hyperbolic gamma is equal to ZOT by Z2. Okay. Now dividing this equation by equation of, that is, if this is 3 and this is 4, then dividing 4 by 3, we get now dividing 4 by 3, we get sine of hyperbolic gamma whole divided by cos of hyperbolic gamma is given by ZOT by Z2 whole divided by 2Z2 or 1 plus Z1 by 2Z2. Okay, this is equal to ZOT by Z2 into 2Z2 whole divided by 2Z2 plus Z1. So this Z2 and this Z2 will get cancelled, and what we get is tan of hyperbolic gamma is equal to ZOT whole divided by Z2 plus Z1 by 2. ओके, वी हैव टेकन, क्या किया हमने यहाँ पर 2 कॉमन ले लिया. So this 2 and this 2 will get cancelled. So this is the, but we know that ZOC is equal to Z2 plus Z1 by 2. Then I can write, and we also know that ZOT is square root of ZOC into ZSC. Then I can write tan of hyperbolic gamma is equal to square root of ZOC into ZSC whole divided by ZOC. Okay, so I get tan of hyperbolic gamma is equal to ZSC by ZOC. Also sine of gamma by 2 is given by 1 by 2 cos of h gamma minus 1. Now we know that cos of h gamma is equal to 1 plus z1 by 2 z2, which is equal to square root of z1 by 4 z2.